Hello, everyone. Welcome to my second lecture at adaptTo. This time, I'm gonna talk about promoting solid code architecture in AEM. I've posted a small poll to get started and to see what you think about applying the MVC pattern when you develop your AEM components. And actually, we got a lot of answers for all or for options. Most of them for using Sling models as the controller and OSGi Services as the model. I'm not gonna give you a correct answer right now, but we will go through it really shortly in the presentation. So let's get started. First of all, I would like to start by introducing myself. So my name is Daniel Strmečki, and I'm doing this talk from my living room from a small town of Varaždin in North Croatia. I work at XIO, which is part of the IBM iX agency family, as director for Adobe practice here in Croatia, and also as a solution architect in one of our AEM projects. So I'm 32 years old. I'm a father to a 4-month-old baby girl, and I'm very interested in topics around Java, AEM, testing, architecture, coaching of developers. I do a lot of blogging also on different Java topics on Bildung, and yeah, I would be happy to connect with you on LinkedIn, so you can see how some links here how to get in touch with me. So that's a bit of an introduction about myself, and let's now take a look at the agenda of what we are gonna go through in today's lecture. So first of all, I would like to start by telling you the story of how I learned AEM and maybe some misconceptions that I had at the time when I was starting to learn AEM. Nowadays, I have 5 years of experience in AEM and roughly 9 to 10 years experience in Java in total. And then we're gonna deep dive into some architectural patterns and what you can observe when you develop your AEM code, especially AEM components. And we're gonna take a deep dive into what is the glue that actually connects all of our code to work together in AEM. Next, we're going to look at applying some architecture rules through unit tests. So how you can ensure that your architectural best practices actually get applied by everyone in the team, on the project, or even in the whole company. And we're going to look at some best practices in AEM development, how to document them, how to create a set of coding guidelines from those best practices, and then finally how to automate the actual application of the guidelines on your project using custom quality rules. In our example, it's going to be in SonarQube. And of course, I will try to leave some time at the end for questions. So let's get started with the first topic, and that is learning AEM. So I already said I started working as an AEM developer 5 years ago. And I came from a company that was using Java, but a different web framework. And my opinion back then and still today is that Adobe Experience Manager is not the simplest framework to learn. So the main reason is, I think, Sling, because Sling works quite differently to compared to most popular choices that other companies and other frameworks use. And I also was very used to applying the MVC pattern in my everyday development in my previous company. So naturally, I wanted to stick to what I know, and I tried applying the MVC pattern also to AEM. The first thing you notice when you start working with AEM is it's hard to apply this because there is no controller Java class in AEM. So I'll explain that in a bit more detail on one of the following slides. When it comes to learning AEM, I'm pretty confident that most of you got some training from Adobe, or at least some of those PDF materials that Adobe is teaching us. And there you will see the explanation of how AEM runtime architecture is working. So, and you, of course, learn that there are AEM modules and Sling and CRX and a servlet engine, everything running in OSGi bundles, and everything, of course, inside a Java virtual machine. But as developers, that is, of course, useful information, but it doesn't teach us and help us much on how to architect and how to organize our code bases. And this is the topic that I would like to focus on today. So let's start by looking at some architecture patterns for our code in AEM. When we do AEM development, usually we do it for larger enterprises that have a kind of an enterprise architecture, and in that terms, AEM is usually in the top tier if we look at an N tier enterprise architecture pattern. That is, of course, the presentation layer. So in the bottom, we usually have some systems that handle data like CRM or RP. We have a suite of business services in the business tier. It can be e-commerce or marketing, whatever. So services without providing a UI. And then Adobe Experience Manager is usually in this presentation layer in charge for rendering the sites for the web. You might argue that with SPA, AEM moves a bit down since it's actually the SPA application that does the rendering. But yeah, that is true. But it's still not very relevant for this topic today. And still, I think AEM is usually in one of these top layers. And when we look at the patterns that get applied in the presentation layer, I already mentioned MVC. And this is, I think, the most popular framework in web development, most popular, pattern in web development today. It's used in a lot of Java web development frameworks, but also in .NET and some other technologies. And of course, when I started working with AEM, I tried to apply MVC to AEM components. And if you look at the right side, it's clear that the view in MVC would be Sightly or HTL. But what would be a controller and what would be a model? That's really tricky, right? So when I started working on my first project, you can see this in a picture below. I actually created 2 Sling models for every component. One I call the controller, and the other one I call the model. And in the model, basically, I just loaded the data that I need from the JCR, and I would do the logic in the controller. And of course, this was my first try of applying MVC, and it didn't work because Sling models cannot really be used as controllers, right? Because Sling just works differently. Sling is actually our controller because Sling is handling script resolution that would usually be handled in a controller in other frameworks that apply the MVC pattern. Instead, later I learned that there is another pattern which fits much better to how AEM is working, and this pattern is called the MVVM pattern. It stands for model view model. And again, the view is, of course, Sightly. But the difference here is there is no direct connection from the view to the model. Instead, the view binds to the methods that are provided by what is called the view model. And the view model is exactly what fits to the Sling models. So Sling model would actually be a view model exposing the methods to Sightly, but also calling and referencing all the business logic that is implemented, hopefully in dedicated components. And in terms of AEM, this would be OSGi Services. Okay, so we saw that Sling models are kind of in the center and gluing everything, all of our code gluing all the business logic together with the data from the database, and also exposing that to the view. And this is what makes Sling models also heavily misused on a lot of projects. So I've seen a lot of Sling models on different projects that become very, very complex, especially if you have a team where not all developers are so experienced in AEM. It's really easy to be tempted to put all of your code into the Sling model. So in the Sling model, you can inject the data from the JCR. You can provide view methods. You can implement your logic. You can inject other services. You can even inject other models. So there's nothing pretty much you can't do in Sling models. And of course, if you do that, and if you don't apply proper separation of concerns, then of course those Sling model classes can become very, very large and also hard to understand and hard to maintain. Here is one example of how I believe a Sling model should be used, should be designed to actually simply just connect the data with the business logic and, of course, expose the getter methods to the view. It's really important to keep it simple because of the fact that this is the glue that connects everything together. When it comes to implementing business logic, I would definitely advise to develop dedicated OSGi services for every piece of code that contains business logic. Here is another example of an OSGi service, and I said implement all of your business logic in OSGi services, and I believe there are two main reasons why we should all do this. The first reason is that OSGi services are highly reusable. So maybe at the moment when you are developing one component, you don't see that this logic is going to be reused everywhere else. But requirements change, and just because you don't see a use case for it now doesn't mean that there won't be a use case in the future. And I think it always makes sense to separate it. It improves understandability and reusability. There is another important reason to do it in OSGi services. That is because OSGi services are easily testable. It's easy to write unit tests for them. It's easy to write integration tests for them. Of course, thanks to the AEM library. And it doesn't really matter if you do test-driven development or you do behavior-driven development. It's easier to test things if you apply proper separation of concerns. I'm not a huge fan of test-driven development, so I don't think you should write a failing test and always start from that. If that works for you, I'm fine with this. But what I think is important is that you write your test together with your implementation, because then your test will also drive the design of your implementation, and that is, I think, the important part. So you don't want to do it later, because if you write all of your tests later, if it's going to be more difficult, and you might need to do some refactorings of your implementation. Okay, so we mentioned some good practices now, and next topic I would like to dig in is how to actually make sure that everyone in the team adheres to certain best practices and rules when it comes to code architecture. So actually, there is a really cool library that you can use for any Java project, not only AEM. It's called ArcUnit, and this is a library. It's linked here. You can look it up in more details. It's a library for actually checking the architecture of your Java code, and it uses JUnit tests to do that. So basically, what you can do with this library is that you can check the dependencies between your different packages or different classes, even create some layers of packages or slices, and make different assertions based on how you want to organize your code base. It also comes with a bunch of out-of-the-box checks, like, for example, checking cyclic dependencies and much more. I don't have time to deep dive into ArcUnit today, but I've posted a link to my GitHub and one of the AEM projects there that has examples of Arc unit tests and how you can use them in AEM. So if you're interested, again, you can take a look yourself. Yeah, once the slides are published. I added some examples on the slides here just to show you what are the things that you can do with the Arc unit library. And let's first take an example of what type of tests you can define for OSGi services. These are really some basics examples to start with. So the first test at the top allows only interfaces. So what it does, it looks for all the classes that are in the services package. And in the services package, since we are using OSGi, we should find only interfaces, right? And we can define a JUnit rule so that no developer can place anything in this package that is not an interface. We can also use it for forcing a naming convention. For example, we can say that all classes that are inside the service package, they should have a suffix service so that we make sure that everyone is following the same naming convention. We can also make different assertions on the code in the classes that reside in specific packages. For example, if we take the services implementation package, we can define a unit test that says that every class that is part of this package should be annotated with a component class. So you could also use this kind of test to make sure that you are applying appropriate annotations and, for example, that you are not using outdated annotations. Let's take another look at two examples how we can apply this library to Sling models. For example, for checking dependencies between packages, for sure you want to allow some dependencies between packages, but you don't want everything dependent on everything. That's just bad code architecture. So here is one really basic example where we say that no class that is a Sling model, and Sling models are in this example in these two packages, should have a dependency on servlets, because that just simply doesn't make any sense. And you can make a rule out of this, and you can check this with your unit tests. The second example here is that, again, no classes that are Sling models should contain static methods. This is, again, one example where with this test, we are actually forcing developers to, if there is something static, that then it should be placed in a utility method instead of the Sling model. Okay, so that was a quick introduction into Arc unit, and now I would like to talk to you about some of the best practices that I've seen during these 5 years that I've been working with AEM, and also how I approached documenting this best practices. So I would like to discuss briefly the value of documentation, because I think in agile software delivery, this is probably the biggest misconception. So there is this agile principle that working software is more valuable than comprehensive documentation. And as developers don't like to do a lot of documentation, they usually forgot about this word comprehensive. And then we end up with no documentation. So documentation is, of course, important. Especially high-level documentation is really important. That helps, everyone understand what we are trying to build here and how everything is supposed to work together. And again, when it comes to architecture, it's really, really important to have clear guidelines and clear documentation. So what I did during my time learning AEM experience on different projects is that I made some notes. I started with some personal notes on some good practices that I saw on different projects. Why I did that? Because eventually we always refer to our previous projects and previous experience, and we have those lessons learned that we learned on previous projects, and we usually copy paste things from our old project to our new project. So I think it's it's a really good practice that when you see something is really working good and you see it as a reusable thing, you want to reuse it in your future projects to also make some kind of note and documentation out of it. I will run through a couple of examples. I will not go through everything, but just some of the things that I want to note down when it comes to different pieces of AEM code base. And first, I want to start with OSGi Services. So we already talked about placing business logic in services, and then you might say, okay, but why wouldn't I place it in utils? Because utils can also be used to place Java code. And my answer would be two things, because actually you would be breaking both single responsibility and open close principle. Because utils class for sure don't have a single responsibility, right? They usually do a lot of stuff. And they are also not very open to extensions. They are to some extent, but not nearly as OSGi services are. Another of these best practices says that you should prefer Sling APIs over JCR. So always use the higher level API. And this is something that I think is also documented in the Adobe documentation. Something that I just took over from them. And yeah, there are some use cases when you want to rely on and use JCR APIs, for example, for performance reasons, but in most cases, we should prefer Sling. One really common example that I think everyone here should be familiar with is that when you open your own service resources over, you are also in charge of closing it. And with Java 8 and 11, this is really simple because there is a try with resource statement, and then when you put your resources over in the try statement, Java will take care that it's immediately closed. So it's just a few examples of things that I noted down. When it comes to Sling models, few examples are to use injector-specific annotations. So if you're not familiar with the term, injector-specific annotations are those annotations where in the Sling model we have separate annotations for different types of objects that we inject. For example, OSGi Services, value map value when we want to bring in something from the JCR database, or for example, Sling object. Before injector-specific annotations, we used to have inject everywhere. And of course, I think injector-specific annotations really improve the readability of the code. And so it's much easier to understand. Another example is to actually log all the runtime exceptions in post construct. You might wonder, why would I want to do that? But well, the reason is because I don't think we should display stack traces to our end users. And if you don't log runtime exceptions in your post construct methods, actually your page will stop working and the end user will see the whole stack trace. This is not a best practice. Those stack traces should go into our logs, and then of course our logs should be monitored for such things. And my last example is to avoid the adaptTo method. Yes, I came to adaptTo conference and I say that you shouldn't use adaptTo. There is one simple reason that it's simply, I think, outdated because it was designed to return null values, and null values lead to null pointer exceptions. And with Java 8, we have the optional class, and we can completely get rid of null pointer exceptions from our logs. And the other example is it's simply harder to mock. So let's look at a page manager example here on this slide. So you could get a page manager instance by adapting the resources over. That's one way, but that's not what I would recommend. I would actually recommend to use the page manager factory instead. It is an OSGi service, and I already said that OSGi services are much easier to mock and to test. So yeah, one of these best practices is also to avoid adapt. With time, this set of notes or best practices actually became our company coding guidelines. And it's really simple to do. It's just sharing your knowledge and your notes with everyone in the company, and also, of course, encouraging everyone to contribute. And I think it's really useful because it helps you align with other developers in your company. It enables you to maybe teach some best practice to someone else, but also you always learn something yourself because other people will also contribute. There is one more important thing to note here is also that you can use such guidelines to also coach junior developers. So instead for them to again learn and go through the same processes as you went through, you can actually try to teach them these best practices so that they can avoid this problems that you or maybe other people in your company already saw based on your previous experience on previous projects. Some of the benefits that I see of coding guidelines, and here on the right side, you can see a screenshot from our Confluence. We have a set of guidelines for Java, we have a set of guidelines for AEM, and a set of guidelines for testing, and we organize them like this, basically per types of classes. And I think this really helps us to boost quality and alignment on different AEM projects that we are running, because we have a lot of them running at the same time. It helps us to learn on the mistakes that others made. I think this is really important in software development, but I think life in general. So you don't want to learn only on your mistakes. You want also preferably to learn on mistakes that others made. Of course, when the code bases are more aligned, it's also more easy to switch people between projects. And when it boosts quality, I think it's also a nice thing that brings competitive advantage, because you can also present this quality KPIs to your clients, and this will also help to expand existing client engagements. Okay, and the last topic for today is custom quality rules. So having coding guidelines written on Confluence or I don't know, somewhere on paper is really nice. But if there is no automation behind it, then it probably won't be used, or at least it won't be used by everyone in the team or in the company. So coding guidelines can actually be automated, most of them, using a set of custom SonarQube rules. That's at least how we did it. These automated checks, together with pull request decoration, and this is my favorite feature of SonarQube. But of course, if you want to use it, you will need to purchase a license, so it's not available in the free version of SonarQube. But it helps ensure that guidelines actually do get applied on all projects. I think if something it's not automated and really simple to use, then it probably won't be used, at least not by everyone. So here is one example. Again, I don't have time to deep dive into this, but it's an example of one of the rule definition, and it's actually the rule definition of the rule that you should always have a try catch in your post construct methods. So just to give you an example that it's not so difficult to write custom SonarQube rules. This project is still under development, and we plan to open source our SonarQube rules. And I'm hoping that maybe next year we can have a more deep dive session into these rules in the next adaptTo. For now, what I want to show you is what these custom rules can bring you as an advantage as an AEM developer. So first of all, for our local development in our IDE, and we use IntelliJ, we use SonarLint. And SonarLint can pull the set of rules from your SonarQube server. And then you get all of these warnings that you would see in SonarQube. You also see them in your IDE. And you have an example here where SonarLint says, hey, you didn't wrap your code in a try catch clause, and it's really obvious. And then you can of course refactor this. We also use Bitbucket. And Bitbucket can also be integrated with SonarQube. And we just started using the pull request decoration feature. Basically, what you can do with pull request decoration is if there is a major issue found by SonarQube in your code base, you can even disable the merge button. So you can say no one can merge the code until they fix all the major issues in their pull request. And there is another cool thing that Bitbucket displays all these issues in the pull request when other people review it. So you could also insist when you do code review, hey, please fix this issue. It's important. And on this slide, you can see an example for our rule or our code smell that adaptTo method should be avoided. So it's not mandatory, but we warn developers that we don't consider this to be the best practice. Okay, so that was everything. So I would just like to summarize what I talked about today. So first of all, AEM doesn't follow the MVC pattern. It is more aligned with a MVVM pattern. It is really important for us developers to have a clear separation of concerns. So definitely don't write all of your code in the Sling model just because you can. And make use of OSGi services as much as possible. They promote reusability, testability, and also, I think, understandability for other developers. Coding guidelines can help you boost quality and alignment between your project teams, and they could be automated using libraries like ArcUnit, using SonarQube rules, custom SonarQube rules. You can actually ensure that they get applied. But of course, creating this kind of internal guidelines, artifacts, custom rules requires, an internal team effort. But I definitely think it pays off in the long term. Of course, I wasn't the one developing all this internal artifacts, guidelines, SonarQube rules. So there is a team of people working on that. So I would like to use this opportunity to thank everyone in XIO Adobe Dev team who worked on creating and also maintaining these internal assets. So this is everything from me today. I hope you enjoyed the lecture. I am a bit over time, but I will take this 5 minutes to answer a couple of questions if there are any in the QA section. For those, if there are questions that I don't have time to answer, I will make sure I answer them offline. So there is only one question for now, and this one is from Lucas, asking what are my thoughts on checking coding structure in unit test versus static code analysis, SonarQube. So basically, yeah, you could do the same things in SonarQube. There are a couple of things to consider. So I think writing unit tests using ArcUnit is much simpler than writing custom SonarQube rules. So if you're short on time, I think you will do it much faster using unit tests. And also you will run unit tests with every build. So developers will see those issues, I would say, earlier. So we actually use a combination of both, as you saw in the presentation, but it is also possible to check the code structure in SonarQube as you suggested. And we have another question from Chris. He asks, why does use of adaptTo make code harder to test? I don't get why it should be avoided. Just to avoid null pointer exceptions, it seems to throw the baby away with the bathwater. So the use of adaptTo, I think it makes code harder to test a bit, because when you mock the adaptTo method, which is again possible with AEM mocks, so you need to register your own adapter. And I think mocking services is just much simpler. You could also refer to my last year's presentation to see an example of integration test that I showed there, where all the mocks are completely separated from the tests. And this, I think, makes tests very, very clean and also easy for everyone in the team to understand. And when you use OSGi Services, then you can easily separate all the mocks from your test code. You do all the mocking in a separate class, and then you just register the mock services into your AEM context. And yes, the other reason is simply to avoid null pointer exceptions. I think adaptTo is of course useful, but it's also a bit outdated. So simply in Java, it's a bad practice to return nulls. And again, you don't really know what happened, what was the reason that this null was returned. It clearly indicates that something is wrong. And when that happens, you want to see a stack trace, and you want to get an exception, and you want to handle it. You want to log it properly. And yeah, last question I'm going to take today, because we need to jump to the next presentation, from Jason. Wanted to know my view on the heavy front-end, heavy applications. Adobe Forms has a lot of action scripts on content. So Jason, I'm going to have to disappoint you, because I have absolutely no experience working with Adobe Forms. But when it comes to front-end applications, so my expertise is mostly backend. But I think in front end, I don't know if there is a library similar to ArcUnit, something similar in JavaScript. Maybe that's something you can simply check out. But definitely you can use SonarQube for your front end code as well. So, and you can develop custom SonarQube rules for whatever, plain JavaScript, React. It should work the same way. Okay, thanks for your questions. That's all from today. See you in the other lectures. Bye.